Welcome back. In this class, I explained three important definitions of probability. What are those? The mathematical definition is also known as classical definition of probability. Second one, statistical definition of probability. It is also known as empirical definition. And third one, axiomatic definition of probability. So by explaining the definitions, you will be knowing that what is the difference and why there are three definitions of probability. What is the need of separate definitions? Okay, all the questions will be answered in the definitions. First one, the mathematical definition of probability. So if we consider there are n exhaustive events, mutually exclusive events, and equally likely events. If we consider n are exhaustive, mutually exclusive, equally likely events, out of which, for example, m, small m, are favorable number of outcomes, then the mathematical definition of probability, it is denoted by simply P, or probability of E. It can be calculated by m by n, that is favorable number of outcomes divided by exhaustive events, that is the total number of outcomes. This is the simple definition of mathematical definition of probability or classical definition of probability. Come to the second one. Mathematical definition of probability fails in some conditions. For example, if I ask a question, నేను ఒక క్వశ్చన్ అడిగాను, what is the probability of an accident rate in a particular junction, in a particular city? How can you answer what are the total number of outcomes? Similarly, what is the probability of a birth rate in a particular state or in a particular country? Then what is the favorable number of outcomes? What is the total number of outcomes? What are the favorable number of outcomes, total number of outcomes? We cannot specify. In such a case, on by observation, in both the cases, if you want to calculate some accident rate, probability of accident in a particular city, then we can have some, we can collect some particular data. Based on the data, we can calculate this much of percentage of accidents are taken place. So percentage is probability 15%, 10%, 2%. Similarly, the birth rate, probability of getting births, probability of female birth. So the percentage of female birth per 1,000 persons. So that is observed. That is going to be, the data is observed. That is why the reason why it is called empirical probability. So hence the reason why the statistical definition of probability was introduced because of these two particular reasons. Second one, if n tends to infinity, that is the number of trials becomes large, then how can we calculate the probability? The question mark. How can you count the number of favorable number of outcomes? How can we count the total number of outcomes? For example, 20 dice are thrown, 20 power 6, 6 power 20, I'm sorry, 6 power 20, the total number of outcomes. For example, I have given that if the sum of the number on the 20 faces is exactly, it is more than 120, then how can we calculate? So it's a tedious process. That exactly statistical definition of probability enters. So in a case where n becomes large, n tends to infinity, in a case where some kind of probability is going to be, that some kind of phenomena is going to be observed with the help of the empirical studies, that is on observation only, by observing the data only, if you calculate the probability, or percentage or a ratio, then it is known as statistical definition of probability. It is only calculated with the help of the statistical definition of probability. Then what is the definition? As per the definition is going to be considered. Whatever you consider some particular random experiment under essential and homogeneous similar conditions, identical conditions, then the limiting value of, that is probability, the probability of E is going to be defined as limit n tends to infinity m by n. That is the limiting value of number of times event happens, that is m. Number of times event happens to the total number of trials, that is n. As n becomes, that is total number of trials becomes large, that is n tends to infinity. You see the definition very clear. Limiting value of the number of times event happens to the total number of trials when the total number of trials becomes large. So that is nothing but probability of P. That is called the statistical definition of probability or empirical definition of probability. It is also denoted by P or probability of E, limit n tends to infinity m by n. This is what the difference between the mathematical definition and statistical definition of probability. By taking these two, another particular definition is defined, that is called axiomatic definition of probability. It is based on three particular axioms, and whenever you consider this, this is going to be considered with the help of the SVP. It is called probability measure. It is going to be considered as a triplet. SVP. What is S? Sample space. B. Borel sigma field, which means which consists of all the events. It is set of all events. And P. Probability measure. Now this is discussion on this particular P. When you say this P is said to be one particular probability measure, which means it satisfies some particular conditions, then only it specifies as axiomatic definition of probability. What is the what are those conditions, those axioms? One, if you consider probability of any event EI, for example, it is always greater than 0 for all I. Whatever the event you consider, the probability of the event, for example EI, is always greater than 0. Okay, always greater than 0 for all I. Then it is called positivity. Okay, that is the first one. The second one, certainty. Probability of the sample space is equivalent to 1. That is called certainty. This is the second axiom. The third axiom, for example, if you consider n events, E1, E2 and so on, En are disjoint events, then probability of, I write here, probability of union I is equal to 1 to n Ei, which can be expressed as summation I is equal to 1 to n probability of Ei. This is called additivity. So these are the three axioms which are called this P is called probability measure. That P is called axiomatic definition of probability, in which any particular P is satisfying these three particular axioms. That is, probability of I is greater than 0 for all I, probability of X is equal to 1, and probability of union I is equal to 1 to n, I is equal to summation I is equal to 1 to n, probability of I for disjoint events. Union I is equal to 1 to n. Ei, it can be expressed as summation I is equal to 1 to n probability of Ei. Then that is called additivity. So any particular P satisfies positivity, certainty and additivity. That is called axiomatic definition of probability. So these three are, now it is generalized. These three are three various kinds of definitions of probability: mathematical definition, statistical definition and axiomatic definition of probability. Thank you.